Hey guys, what's going on? I hope you guys are enjoying life at the moment. It is so beautiful outside. It is March 9th, 10 a.m. Make sure to go outside and enjoy it. It's not sunny. It's kind of overcast, but the temperature is nice. It feels awesome. So make sure you go outside and get to enjoy it. I don't know, maybe go outside and take care of this assignment outside. I mean, I don't know. It sounds like a good idea to me. I would go outside, guys, but I don't have a table outside, so I would have to stand, which is not a big deal, but it's kind of hard to write while standing on a tablet. Anyways, let's go ahead and get started, guys. Let's go ahead and do this question. This is from the 2003 AP exam, no calculator. So let's see what we got here. A coffee pot has the shape of a cylinder with a radius 5 inches. All right. As shown in the figure above, let H be the depth of the coffee in the pot. Okay, that makes sense. Measured in inches, where H is a function of time. T measured in seconds. Okay, the volume V of a coffee pot in the pot is changing at a rate. Okay, let's read it. Let's read that again. The volume V of the coffee pot in the pot is changing at a rate, so that cubic inches per second. So that is your dV/dt. dV/dt. The volume V of a cylinder with radius r and height h is V equals pi r squared h. Okay, they're being nice. I don't think they wouldn't have to tell you something common like this one. I would hope that you would know that, but they did give it to us in this one. Show that dH/dt equals negative square root of h over 5. All right, dH/dt. Let's see. I got dV/dt. All right, here's the man. I can't even talk. Here's the game plan, guys. I already have volume, and notice that I have dV/dt. So I'm going to go ahead and find the derivative of volume with respect to time. Now, every time I take a derivative of a variable, it's going to have to be dr/dt or dH/dt, right? So I see here that volume equals pi r squared h. But, okay, here's the thing. R is always a constant. So that means dr/dt is 0, or you can just hold it as a constant, guys. So I'm going to write volume equals pi r squared h, and pi r squared is a constant. So I'm going to write dV/dt equals pi r squared dH/dt. If you wanted to expand doing product rule with r squared and h, that's fine. And then when you plug in the dr/dt is 0, you're going to get the same equation anyways. All right, so now it doesn't look like this. Travis, I don't see that anywhere. Well, we're going to have to solve for dH/dt, guys. What we're going to do now, we're going to plug in what dV/dt is. dV/dt is negative 5 pi square root of h. So here we go. I'm going to go this way. Negative 5 pi square root of h, that's your dV/dt, equals pi r squared dH/dt. So now you're done with calculus, and all we're going to do is just good old algebra, guys. The pi's cancel out. Let's see. Get rid of the r squared. Oh, well, actually, no. Don't get rid of the r squared. R is 5 inches, so you can plug it in already. Negative 5 square root of h equals 5 squared dH/dt. And I'm going to divide by 5 squared. Divide by 5 squared. And check it out. One of these 5s cancels out. Bam and bam. Because that's 5 times 5, right? So now, what do you have? You have dH/dt equals a negative square root of h over 5. And I probably should have done it neater than that. My bad, guys. But there it is. And it worked. Happy face. All this without a calculator, guys. Let's see, given that h equals 17, h is 17, and t equals 0, solve the differential equation dH/dt equals negative square root of h over 5 for h as a function of t. Okay, so what they want, look what it says here. They want you to solve for h. h of t equals something. So what we're going to have to do is we're going to have to separate the variables, the h's with the h's and the t's with the t's. So I'm going to, let's see, I'm going to divide by the square root of h, and I'm going to multiply it by dt. So here's what we have. dh over the square root of h equals negative 1/5 dt. I'm going to rewrite this a little better, guys. I'm going to bring this up. So I'm going to write h to the negative half, dh equals negative 1/5 dt. And now I'm ready to integrate. Integrate, integrate. So let's see what we have now. Add 1, divide by that. So this becomes h to the half divided by half, which is the same thing as 2, equals negative 1/5 t plus c. I feel like this is a good time to plug in this. So let's plug that in. So let's see, h is 17 when t is 0. So 2 square root of 17 equals negative 1/5 times 0 plus c. So there it is. So that gives me that c is 2 square root of 17. So since here's where we plugged it in, here's where we're going to start again. So 2 square root of h equals negative 1/5 t plus 2 square root of 17. So get rid of the 2, divide by 2, divide by 2, divide by 2. So here's what we now have. We have the square root of h is equal to negative 1/10 t plus the square root of 17. And now what you got to do is you got to square it. Whatever you do to one side, do to the other. So h of t is equal to negative 1/10 t plus square root of 17, and the whole thing is squared. And I probably should have given you guys more room, but I think that's good enough right there. All right, guys, let's see letter C here. At what time t is the coffee pot empty? Well, the coffee pot is going to be empty whenever the height is 0, right? Because when the height is 0, that means that you have no more coffee because you're down here in the bottom. So we're going to solve for when h is 0. So I come back, and I'm just going to go 0 equals, and what am I solving for? This equation here. 0 equals, parenthesis, negative 1/10 t plus the square root of 17 with a square on it. Square root, so the square root of 0 is still 0. So negative 1/10 t, I like to write this on the left-hand side here, guys, plus square root of 17 is equal to 0. I'm going to move this guy to the right. Negative 1/10 t equals a negative square root of 17. And I'm going to multiply by negative 10. So whatever you do to one side, do to the other. Oops. That looks like I'm subtracting there. So I'm multiplying. So there we go. So we're going to have t equals negative times the negative of the positive. So 10 square root of 17. And there it is, guys. Short and sweet. Let's check to see if our answers are correct. This one's from what year? 2003. Now, I did look at the question, but I haven't looked at the rubric just yet. I'm imagining it's going to be looking pretty similar to that because it looks like it's just a pretty straightforward question, guys. For your response, A, B, scoring guidelines, 2003. Question 5. All right, so let's see how we did. Yeah, dVdt 25. Yeah, that's that 5 squared. And yeah, we did just that. So I think we got all 3 there. They didn't write h of t. They should have, but that's no big deal. H of t is equal to that. Where did they solve for c? They solved for c where we solved for c. That's great. I would always do it that way, guys. I don't see any other. I mean, you could solve for the equation and then solve for c, but I think that's the best way. Notice a little note here. Max 205 if no constant of integration. That means that plus c there. So when you take your integral and you don't have the plus c, the max you can get is 2 points. And then the answer. Yeah, so pretty straightforward, guys. I think more than likely when you do this, your answers are going to look almost verbatim to this one. Maybe here you write negative t over 10. But other than that, I don't see it changing much. It's pretty much going to look exactly like the rubric here. But yeah, so let me know how you guys did, and I hope you guys have a fabulous day. Give it a thumbs up if this video helped. I guess you can give it a thumbs down if you want to, but don't give it a thumbs down, guys. We're all having a good time. All right, talk to you guys later, guys. Later. Bye-bye.